Hey, okay, I am going to just talk through the strategies that I saw students using for the triangle today and for the trapezoid today. We didn't talk about the parallelogram in any of our classes, so we're going to hold off on that. That's something you'll be working with tomorrow. So we've got this roof. The roof no longer has to be a rectangle. So for this first one, we've got a roof that is triangular. And I got some different responses on why it might be useful to have something that's not a rectangle for the roof. Maybe it's going to give you more area, possibly. It might just look more interesting. So, given that, we've got a triangle here. Our first triangle is our first shape is a right triangle. It's got that right angle, and it has a 9-unit leg and a 12-unit leg. Now I know the same criteria as previously. It has to have a perimeter of 36 units. So, based off of that, I could figure out this last leg, that hypotenuse as well. I could say I'm going to start with my 9 units plus my 12 units, and that gives me 21 units so far. And then my perimeter is 36, minus the 21 units is going to leave me with 15 units for that leg. So I have all of the information about my garden, and I know it's going to be 36 units all around. I want to find the area. And you have strategies for finding the area of rectangles. At this point, you have a formula that you've been using. You've been saying, I take the length, I multiply it by the width, I'm going to have the area of this rectangle. So students started finding ways that they could use a rectangle to approach this shape. I saw many students double that triangle and flip it over so that you now had a rectangle. In that rectangle, we have a 9-unit height and we have a 12-unit length. You can find the area of that entire rectangle. Do length times width, which is going to be 12 times 9, and that is 108 squares. But that's the entire rectangle. So how would I get back down to just to the triangle? Cut it in half. So I can do 108 divided by 2. And I have that the area just of my triangle is going to be 54 square units. And that's what a lot of students did for this problem. Then I asked you about the area of the glass walls. So if this is our roof, if you were to take it like this, or maybe better like this so that you can kind of still see it, how many walls are going to be coming down from there? You've got one that's going to be coming off of this side of the triangle, one that's going to be coming off of this side of the triangle, and one that's going to be coming off of this side of the triangle. So we're going to have 3 different walls that are coming down. Those walls are still going to be rectangles because they're parallel up here and they're parallel down there. So we've still got rectangle walls, and we have 3 of them. I want to know about the glass that's going to cover those walls. So good idea here would be to draw out the walls. I know that one of my walls is going to need to be 20 units high. Well, actually even better, I know all of my walls are going to be 20 units high. So I can just get that set up. And then I know that one of my walls is going to be 12 units long. One of my walls is going to be 9 units long. And one of my walls is going to be 15 units long. And that's because that wall is the one that's going to be coming flush against that roof. At this point, people used what they knew about finding the area of rectangles. Length times width, length times width, length times width. So the area of my first one would be 12 times 20, which is 24 squares. The area of my second one is 9 times 20, which is 180 squares. And the area of my third one is 15 times 20, which is 300 squares. I had students in 7B saying that if you wanted to find the total, you would have to add it all, because total, you're combining things. So you would have the total glassed area would be 240 plus 180 plus 300, or 720 squares. 720 squares. Looking at that, thinking about the rectangular prisms that we made on Monday and that we talked about on Tuesday. Those also had a an area of 720 square units. So it seems like even though the shape has changed completely, it's now a right triangle, it's not a rectangle at all, the amount of glass needed is going to remain 720 square units. So that's interesting. Now you've got strategies for finding the area of a rectangle, strategies for finding the area of a right triangle. How could you apply that to a more complex looking shape, such as a trapezoid? So for our trapezoid, we've got a lot of information about lengths here. Let me write down what we've got. So our trapezoid has a height of 4 units. It has 3, 10, 3, so a total length of 13 units down here. Given that I see a rectangle here, I know that if it's 10 down here, it's going to be 10 up here. And then this diagonal length is a 5 units. So thinking about what's going to be helpful here. A lot of students saw that and they were like, oh, well, I know about rectangles, I know about right triangles. What if I try breaking some of these down into rectangles and triangles? And they noticed that you've got a triangle here, a rectangle here, and a triangle there. And so students did that. They said that would be the same as doing a 3 by 4. A 3 by 4 triangle, a 4 by 10 triangle, and a 3 by 4 triangle. And the reason it's 4 all across is because this height is going to stay the same. No matter where you are in here, it's still going to be 4 units tall. Finding the area of these, students were thinking about how they could use doubling and turning it into a rectangle. Thinking about this one, well, length times width. The area of this is going to be 40 squares. So for this guy, we know that the area is 10 times 4, or 40 squares. And the area of each of those triangles, if we turn them into rectangles, we would need to do 4 times 3, which is 12, and then cut it in half to get 6 squares. On both sides, since both of those are 3 by 4 triangles, just kind of flipped around, they're actually both going to be 6 squares. So you have 40 squares plus 6 squares plus 6 squares. Total area is going to be 52 squares. So that was something a lot of students were thinking about. How could they decompose or break this shape down? If you're finding the area of the glass wall for this one, if this is the ceiling, right, the roof, now instead of having 3 sides like we had for the triangle, we once again have 4 sides, because you're going to have a wall that comes down off of this one, a wall that comes down off of this, a wall that comes down off of this, and a wall that comes down off of this. So in order to find that, you could draw each of those walls out and then find the surface area, find the area of each. Okay? So with your homework tonight, you've got trapezoids, you've got parallelograms, you've got right triangles. I want you to think about the different strategies that you have, whether it's breaking a shape down, whether it's doubling that shape to make a or to make a rectangle, so that you can approach how to find the area for that problem. Tomorrow you're going to have a chance to apply this to doing some actual buildings. See ya.